recorded.
Okay, yeah, inverse tangent. Thank you, Gene. Okay, so inverse tangent. So the integral of 1 over x squared plus 1 is the inverse tangent, okay, of x. Inverse tangent of x. Okay, evaluated from 1 to infinity. Okay, that's kind of interesting. Okay, so what is the inverse tangent? Let's say the limit as t goes to infinity, right? So what we really want to do here is we don't really want to do this. What we really want to do is we want to say the limit as t goes to infinity of the integral of 1 to t of 1 over x squared plus 1 dx. Okay. So then we could say that the limit, okay, as t goes to infinity of the inverse tangent, okay, of x from 1 to t. So then this is the limit as t goes to infinity of the inverse tangent of t minus the inverse tangent of 1. Okay, so what is the limit as the inverse tangent goes to infinity? Well, we have to know something about the graph of inverse tangent. And the graph of inverse tangent looks like this. Okay. Looks like that. And we've got some asymptotes here, okay, for inverse tangent. And this is at pi over 2 and negative pi over 2. So the limit of this thing as this goes to infinity, well, is pi over 2. Okay, so this is pi over 2. The limit, this thing approaches pi over 2. Inverse tangent will approach pi over 2 as t gets bigger and bigger and bigger. Okay. Minus, well, what's the inverse tangent of 1? Well, if I were here at 1, the inverse tangent of 1 would be halfway up, which was what? Well, it's half of pi over 2. Well, that's pi over 4. So pi over 2 minus pi over 4, that's pi over 4. Okay, and so this equals a value. Therefore, since the integral is convergent, okay, since the integral 1 to infinity of 1 over x squared plus 1 dx converges, then what can we say? We can say that the original series as n equals 1 to infinity of 1 over n squared plus 1 also converges. Okay, so this is convergent. Convergent. Okay, that one converges. Okay, one thing to make note is that there's something called the p-series, okay, which is the summation of n equals 1 to infinity of 1 over n to the p power. Okay, this is called the p-series, and this is convergent if p is greater than 1, and it is divergent if p is less than or equal to 1. Well, we already know what it is when it's equal to 1, right? What happens when p is equal to 1? What do we get? We get the summation n equals 1 to infinity of 1 over n, which is the harmonic series. Right? That's the harmonic series. And we saw that the harmonic series did what? Well, it diverged. It's a p-series with p equal to 1. Diverges. Diverges. Okay? Whereas when we did 1 over n squared before, okay, we saw that this thing actually converges, which should make sense because it's a p-series greater than 1. It's p equal to 2. Okay. Okay, let's do a proof of this. Let's do a proof. Let's prove this true. Okay. I'm going to go proof by integral test. Okay, I want to prove this true. We'll call this a theorem. Theorem. Okay, P series will do this. Okay. Proof by integral test. Okay, let's see what happens when we take the integral of this thing. 1 to infinity of 1 over x to the p dx. Okay. So let's take let's see what happens. See what happens here. Okay, so this is the limit as x goes to infinity of the integral. Sorry, t goes to infinity. It should be t. T goes to infinity of 1 to t of 1 over x to the. I'm going to rewrite this as x to the negative p. If that's okay with you. Dx. Okay. So now we have 1 to the t. So we just want to integrate this. Well, let's just use the power rule. The power rule states that I'm going to add 1 to this thing. Right? I'm going to add 1 to this thing and then divide by the reciprocal. So this should become negative p plus 1 all over negative p plus 1. Right? Evaluated from 1 to t. Okay, using the power rule. So limit as t goes to infinity. Okay, cool. Okay, so now what are we doing? Well, we're integrating with respect to x. So I'm going to plug in my t and I'm going to plug in my 1 here. Okay, so this is the limit as t goes to infinity of t to the, I'm going to go 1 minus p. I'm going to just change the order. All over 1 minus p. Okay, minus x to the negative 1 plus 1 over 1, what's this? Over negative 1 plus 1. Okay. Is that right? Think about that for a second. Oh, no, this is not right. This should be p. This should not be this. This is wrong. Sorry, this should be x, not p. I plugged in wrong. So this is 1 to the 1 minus p over 1 minus p. There we go. That makes more sense. Okay, I'm like, I knew I made a mistake there. Okay, I'm not plugging in for p, I'm plugging in for x. Okay, so what is this? This, okay, is the limit as t goes to infinity. I'm going to factor out the 1 over 1 minus p. This is going to be t to the 1 minus p minus 1 to the 1 minus p. But 1 to the 1 minus p is just 1. That goes to that guy, right? Okay. So this is equal to the limit, okay, as t goes to infinity, okay, of 1 over 1 minus p times t over t to the p, okay, right? Does that make sense? Okay, I just kind of brought that t to the p downstairs because it was a negative p minus 1. Okay. So let's do another step here. The limit as t goes to infinity of 1 over 1 minus p to the 1 over t to the p minus 1, because one of these p's one of these t's is going to cancel with one of these t's, and I'm going to get one less t on the bottom, minus 1. Okay, so now I'm ready to plug in. Okay, for infinity, what happens if what happens when I get 1 over infinity? Don't I just get 0? Okay, so yeah, I do. So this is just going to be 1 over 1 minus p to the negative 1, or times negative 1. Okay, so this is just equals the limit, or sorry, not the limit anymore. This just equals 1 over 1 minus p. We took the limit already. Okay, times negative 1, which is just 1 over p minus 1. Okay. Okay. And so we want to know, okay, so this is the integration. When is this thing going to converge, and when is this thing going to diverge? Okay. Well, keep in mind, you know, what's the original thing that I'm testing here? I'm testing the sum of n equals 1 to infinity of 1 over n to the p. Okay, and I want to know for what values of p does this thing converge, and does this thing diverge? Basically, if I do 1 over x to the p, 1 to infinity, right? Dx, when does this converge, and when does this diverge, right? And so keep in mind that p here is an exponent. P behaves like an exponent. This is an exponent. Okay, so it's an exponent, and so I want this to be, we want to talk about positive exponents or negative exponents. Okay, so if, how can I say this? If this thing is equal to a positive number, if p is greater than 1, and it's equal to a negative number if p is less than 1. Does that make sense? If it's less than 1. Okay. Okay. So this is the sum. Think of it as this is the sum of all the area under the curve x to the p power. Okay, that's the sum of all the area under the curve x to the p power. Or sorry, 1 over x to the p power. Okay, 1 over x to the p power. So think of it like this. If we have, if p is 1, this thing is kind of undefined. Okay, but we know what happens when it is equal to 1. It's divergent. Okay, it's divergent because it's the harmonic. Okay, but if this thing is positive, what's going to happen? What's going to happen? If p is positive, then the area is a positive value. It's positive area. Okay, it's positive. Okay, it's a positive number, and so it just is a number. Okay, so say we let p equal to 2, right? Say that we let p equal to 2. Then what do we get? We get an area of 1 over 2 minus 1, or 1. So we would say that the area of 1 over x squared from 1 to infinity, using the integral test, that equals 1. Okay, so it converges. Okay, and then any p greater than that will also equal a number, a positive number, right? But what happens if p is smaller than 1? Let's see what happens if p is smaller than 1. Well, if p is smaller, when we get a negative number, right? We get a negative number here. Okay, and so we'll say, well, let's say that P is 1/2, right? Let's say that positive, okay, it's negative if P is less than 1. So say that P is 1/2, P equals 1/2. Then we get 1 over 1/2 minus 1, which is 1 over, what? 1 over negative 1/2. Okay, okay, interesting. So this would be equal to -2. And so they're saying that the area of this thing would be -2. Which is kind of weird. Kind of weird to think that, okay, the area is -2 when we start off positive. But what does this mean? This means that the integral from 1 to infinity of x to the 1/2 power, okay, x to the 1 over x to the 1/2 power, okay, is equal to -2. Okay, and that doesn't make a whole lot of sense. Let's see what happens here. Okay, let me go back to the calculator real quick and see, can I even figure out what this looks like, the graph of this thing looks like? Well, this is 1 over, let's think about it this way. This is 1 over x to the 1/2, which is x to the negative 1/2 power. What does that even mean with respect to, this is 1 over radical x. Hello? Did it freeze again? Did it? I can't believe this. It's cool. It froze again. It froze again. This is not working for me.